This week's unit is mass wasting. And so here are the week's questions for discussion. Would you live on a slope? So mass wasting is really the mass movement of large amounts of material down a slope. So would you live on a slope, because that's where this is going to be the hazard? What level of risk from mass wasting is acceptable to you? And as we go through the material, we will discuss like how do you know if this is a risk, and also several different types of slope failures. And then what should be done by people and communities in areas prone to slope failure to prepare for the hazard and prevent a catastrophe. And this is kind of one of the interesting hazards in the sense that it's definitely a hazard in the Illinois Valley. It's not very well recognized as such. But the other thing is this is a hazard that most people can go out and evaluate to some level just on their own, which is kind of fun. So some other questions to consider as you're doing this, as you're going through the material this week. What factors are going to impact the stability of a slope? And of course, we want to look at and remember the 5 concepts from chapter 1. So mass movement is just very simply the downslope movement of earth materials under the influence of gravity. Pretty straightforward. The impacts can be pretty dramatic. Structural damage and surface disruption. So you can see these are some examples of a slope failure that's taken away part of a highway, and one in California that took out part of a neighborhood. So these can be very damaging on a large scale. These are very dramatic pictures, but some of the other pictures that you don't see as much is that very often houses that are on unstable slopes will just slowly move downhill. There'll be a slow shift, and over time the foundation will get torn apart. Plumbing, water lines coming into the house can get damaged. Electric lines, all kinds of things coming into the house can get damaged as the land under the house very slowly moves downhill. And the house itself can get shifted, no longer be even. So the dramatic stuff, the stuff that you see in the pictures on here, is what captures a lot of people's attention, but it's that slow failure very often that causes more problems to people and that is much more common. So what kind of factors are we talking about? Well, it's pretty straightforward. It's what you would think it would be. Number one, the angle of the slope. The steeper the slope, the higher the risk. You can see in the background they've got some straight up vertical cliffs. But most slopes that we look at aren't that dramatic. They're a much lower angle. And so then we want to bring into our discussion things like, what material is this slope made of? What's the orientation of the materials in that slope? And you can see in the lower drawing here, you can see they are layered rocks. And if the layers are parallel to the slope, as they are in this case, that can be a more dangerous situation than if the layers are dipping into the slope. Sometimes that can add to stability. So the orientation of the layers, but also what is that material? Is it something that gives way very easily, or is it much more solid material? And then the second bullet point you see up there is water content. Water is very, very often a major player in slope failure. You're going to see that on the next slide where we talk about triggers. Some other things that are going to impact the stability of a slope that could be complicated. Vegetation is a good example, because if you add some vegetation, very often that makes the slope more stable, because the vegetation, the roots tend to hang on to the material and they tend to soak up water. So those are good things. On the other hand, as vegetation grows and gets bigger, it can add more weight to the slope, which is the next bullet, the loading of the slope. The loading of the slope can happen due to human activity. If we build buildings and move earth around, that can change the loading of the slope. But vegetation, like I said, can also add load to the slope, which generally speaking tends to be not good. Undercutting. The slope, the lower parts of the slope very often are supporting the upper parts of the slope. So if you pull away material from the lower part of the slope, in the drawing you see here, that's been done through construction activity, but natural activity can do that as well. In the picture up on top, the waves are slowly tearing away at the base of the slope. And rivers can do something very similar. So undercutting a slope can destabilize the situation. And then, of course, over time, the weathering of materials. You could have some very good natural materials, very solid, very stable, but over time, those materials can break down due to weathering conditions, and as they slowly fall apart, the slope can become less stable over time. So those are all important considerations, what we call slope factors, when somebody's evaluating a slope and how stable it might be. And then there are triggers. So what actually causes some of these dramatic slope failures? Very often it's rainfall, because rainfall, a heavy rainfall especially, can add a lot of water to a slope in a short period of time. A flood at the base of the slope can undermine the slope. That's where we come up with undermining, but natural human activity can do that as well. And vibration, so earthquakes very often can trigger slope failures. So these are all things that can actually trigger the movement and cause something dramatic to happen. We classify slope failures because that helps us kind of understand the processes that might be active on a certain slope. And there are some large groups we put things into. Slides are where a large section of material slides as a unit down a hill. A flow, on the other hand, is when the material gets very mixed up and kind of flows incoherently down the slope. And one of the things you'll see in the middle on the right-hand side of that slide is where you get a combination. It starts out, that slump is classified as a slide, but as the material moves down the slope, it can become jumbled up and turn into a flow. And very often we see this kind of complex slope failure, where it starts as a slide and then becomes a flow as it moves downhill. Falls are really usually individual rocks falling off the side of a hill. Also very, very common. Very often also less dramatic unless it's a really large boulder. The fourth bullet there is creep, and this is the one that catches a lot of people off guard. Creep is a very slow movement of the top of a slope downhill. And creep is typically going to happen over the course of many, many years as that material very, very slowly, as the name implies, creeps down the hill. Now that might sound like something most people could deal with, but if you don't know it's occurring, this is the kind of slope failure that can very slowly tear apart a house or other structures, because the movement of the material is long-term and it's constant, and it essentially tears things apart. And then the last one is an avalanche. And typically when we talk about avalanches, we're talking about snow avalanches, where that loose snow material falls very dramatically and moves down the hill. But then it's gone. It melts. It goes away at the end of the year. So for the slope failures above, you can go there kind of any time and look for evidence of the slope failure. Avalanches, after they happen and the snow melts, they're gone. So in that case, you very often have to look for evidence that the avalanche has happened in the past, because they will tear apart trees, they'll make pathways down slopes, and so those are some things you can look for in terms of avalanches. So what do we do about this? How do we address an unstable slope? Well, step number one is identification and mapping things out. Where is this a risk? Where are the steep slopes? And particularly, where are there steep slopes that are made of materials that are likely to fail? You put those things together and you can make some slope hazard maps. You can also look for evidence of movement on a slope, and then you can map out what they call landslide inventory maps. So showing not only where the unstable slopes are, but where the active and identified failing slopes are located. You can then monitor those slopes. Once you know there's a risk, there are multiple ways to monitor things. You can just survey it in on a regular basis, but you can also install certain pieces of equipment that will, as they change shape, So if the slope is failing as that material changes its shape, it will send an alarm or produce some kind of alert. And then there's stabilization. What can we do to make a slope more stable? And there's some pictures on here of some of the things that are done that include retaining walls. If you remember, vegetation can be a stabilizing factor, so you can plant vegetation, certain types of vegetation that have lots and lots of roots and are going to soak up water. You can also do other things that will keep water off the slope. Some of those things are on the surface. You can see like a surface drain on the picture on the right-hand side of this slide. But you can also do underground drains, so things that will collect water that's below the surface and take it away from the slope. So, and then there are structural controls. You can see there's a picture here of retaining walls with flowers growing. That's a structural control. But there are also places kind of in the very center of those drawings. There is a place where they're actually spraying concrete on the top of the slope in order to just stabilize all of that material. And there are other structural controls that are mentioned in the textbook. So that's a general overview of mass wasting and slope failure.